Welcome to MiceTechTalk with the technical information scientists of the Jackson Laboratory. My name is Dr. Caitlin Gilland, and I'm joined today with my colleague, Dr. Danielle Fontaine. And my job as a technical information scientist is to serve the research community by answering all of your mouse-related research questions. MiceTechTalk is a way for us to connect with the research community and answer some of your mouse-related questions live. So in this episode, we will talk about how to mimic human metabolism and why temperature plays a critical role. And so we're going to discuss the question today of, would studying mice at thermoneutrality be a more productive model for the effect of drug efficacy on human obesity? So for those of you who are watching live, you can use the comments section of the video and tell us where you're tuning in from. We always love to hear from our viewers. And be sure to insert any metabolism and temperature related questions that you might have, and we'll try to answer those live for you today. So hopefully you're ready with your questions because it's time for MiceTechTalk. So today, let's talk metabolism and temperature. So first, I think it's really important to understand what thermoneutrality is and what is thermoneutrality for humans and mice, and why is it important to know that they're different.
Sure. So hi, everyone. My name is Danielle, and I also work at the Jackson Laboratory. My background, and one of the reasons that I think this topic is really cool and really important, is all of my training was in diabetes, obesity, and metabolism. And thermoneutrality really plays a big role in how you interpret results from any type of metabolism study, especially when it comes to obesity and diabetes. So thermoneutrality is actually the temperature at which your core body temperature is able to be maintained at its ideal rate. And oftentimes we think about, if you're shivering, it means you're a little bit too cold, or if you're sweating, you might be a bit too warm. And when you're feeling really comfortable, that's when you're at thermoneutrality. So this is going to be different for people and mice, which is one of the reasons we're bringing it up for today's talk. So as you can imagine, humans are a lot bigger than mice. We have a lot more surface area on our body that heat is going to dissipate from. So we actually have different thermoneutral ranges from one another. Because mice are smaller, they don't have quite as much surface area. They're not able to get rid of heat as much. They're not able to wear clothing the way that people are able to wear clothing, or be underneath blankets if they get cold. So thermoneutrality for humans is usually somewhere around 22 degrees Celsius. This is somewhere around 70 degrees Fahrenheit. This is the temperature most of us probably keep our homes. You might throw on a jacket if it gets any colder. Mice, however, because they're so much smaller and have a higher metabolic rate, they hit thermoneutrality closer to 30 degrees Celsius, which is about 86 degrees Fahrenheit. So it's quite a big difference. The reason this is important is that the people who are working in mouse rooms want to be as comfortable as possible. And if we kept all of our mouse rooms at 86 degrees, people would be pretty unhappy. There would be a lot of sweat. People wouldn't be as thrilled. So we actually tend to keep all of our mouse vivaria quite a bit cooler than that. We usually keep that at about 22 degrees, which makes it a bit more difficult for the mice. So it's important to understand that thermoneutrality is going to be different, and housing mice in conditions that are thermoneutral for us versus the ones that are thermoneutral for mice are going to be important to keep in mind when you're planning your experiments.
Yeah, so what happens if you don't keep your mice at thermoneutrality? What are some of the things that the mice experience?
Yeah, so by keeping mice at 22 degrees, so at about 71, this is a lot colder than the 86 that they want to be at. So they're actually going to go into something called a regulated hypothermia. This is something humans do not experience because we're able to regulate our body temperature. You might go outside and be a bit cold for 20 minutes, a half hour, but that's not really going to affect your metabolic rate the same way as a female mouse going through pregnancy, giving birth, and then growing up all through your life at what's really considered a cold stress environment. So this is going to lead to metabolic adaptations for cold stress in these mice that are housed at these colder conditions.
Yeah, I saw a statistic in a publication once that said mice kept at 22 degrees Celsius actually spend about 42% of their energy accounting for being cold.
Yeah, so this actually leads us into a really interesting topic. A really specific example of why it's important to know what your mice are being housed at is actually if you're studying obesity. So, as Caitlin just mentioned, mice that are housed in these really cold conditions spend anywhere from a third to half of the energy they consume on staying warm. Um, their mitochondria go through some really interesting adaptations in order to make sure that they're able to maintain their core body temperature, which is very similar to humans. So, humans tend to be happiest at about 37°C. Mice are happiest at 36.6 degrees Celsius, and they're spending all of their energy on that. So one of the coolest things is if you take a mouse and you keep it at this colder, chillier environment. If you give them something like a high-fat diet, or you have a genetic mutation that causes them to eat more than a normal mouse would, something like a hyperphagic mouse, a lot of the energy they're getting from that food is going to staying warm. So while they might gain weight and become obese compared to their control counterparts, if you actually take both of those mice and house them at a thermoneutral temperature, so that 30°C, more of those calories can now go to just putting on fat deposits instead of trying to keep them warm. So a lot of times we'll see mice actually become significantly more obese if you house them at their thermoneutral temperature. And this is important when we're looking at anti-obesity drugs that we're trying to translate to human use. So humans, as I keep mentioning, are not living at this really cold temperature. Humans do not spend a lot of energy on keeping warm. So if we eat excess amounts of food, those things are being stored as fat, similar to what we see in a mouse model of obesity at 30°C. And that brings me to another kind of interesting point is that there's a lot of drugs that are used in anti-obesity studies that are hoping to be translated to human use. And these actually have really different metabolic effects depending on how you house these mice. So if you're looking to do a preclinical trial in a mouse for an anti-obesity drug, knowing what temperature you're working at is going to be pretty important. There are some examples of drugs that are often used to increase your energy expenditure and mitochondrial activity rates. You can imagine that if you're working with mice that are really, really cold, it's not going to work as well. So those mice are going to be increasing their energy expenditure by trying to stay warm. So those mice may not lose a lot of weight on your anti-obesity drug because all of the results from all that extra energy expenditure just make it easier for the mice to stay warm. So you might consider doing some of the drug work and preclinical efficacy work at mice at thermoneutral temperatures to better mimic what you're seeing in a human model.
Yeah, that's great. What about in exercise studies? So where maybe you're trying to lose weight.
Yeah, and that's a really popular set of studies that are often done in mice. You can take mice and single house them, put them with a wheel in their cage and measure how often they're using that wheel. A lot of times you can give them therapeutics to increase energy expenditure, which you're going to see by an increase in use of the wheel. These are often used as starting points for human studies for increasing energy expenditure or finding molecular pathways through which you can actually increase activation of the same tissues that exercise would increase. As we keep saying, these mice are kind of under chronic metabolic stress when they're housed at 22 degrees. And we find that if you actually move them into a housing that is 30 degrees and raise them in that situation, they tend to exercise quite a bit more. It is pretty controversial in the literature. Different people have reported different amounts of exercise between 22°C and 30°C. But in general, it seems as though these mice are actually more thermoregulated, so they're happy to go use that wheel. They're not trying to huddle and keep warm. They might be concentrating more of their time on nesting materials and creating ways to keep themselves warm versus a voluntary exercise type program.
Yeah, great. We did just have a question come in from our audience, so this is a great time for me to remind our viewers to go ahead and submit questions. Want to say a quick shout out to Ella. Hi, Ella, and hi, Gina. But we do have a question that is, how much do lab temperatures fluctuate around the world, and what kind of impact does that have for reproducibility, and how should we manage those differences? So I can make a quick comment on how temperatures fluctuate around the world. There was a recent study done in eLife looking at metabolic data from different labs in different countries. And what the study found was that the lab temperatures really fluctuated anywhere from 18 degrees Celsius to 30 degrees Celsius, which is a huge range. The study found that a lot of labs in the UK and Germany were at a lower temperature, so closer to that 18 to 21 degree range, whereas labs in Japan and Canada were much warmer. So that's just something to keep in mind. How might we consider managing some of these differences?
I think that's a great point. I think one, it's super important to know that regionally the lab temperatures might be different, but even within your own vivarium, there's going to be a lot of differences that might be occurring between facilities. Most mouse facilities have a range that they keep their temperatures in. A lot of times it's between 18 and 23 degrees Celsius. But if we actually think about that, that's anywhere from 65 to 70 degrees. We might see differences there. The best practice is always to just put a little blurb in your method section if you know that there's a particular temperature that your mice are housed at. It never hurts to say all of these studies were conducted in a facility that's constantly maintained between 18 and 23. Some facilities maintain at 25 Celsius, some maintain at 27. Just having that information in your method section is going to be critical for other people who are trying to take conclusions from your study or trying to reproduce your study. Even a couple degrees Celsius can make a huge difference in metabolic outcome. So that's just one thing to keep in mind when you're going to publish, or if you're wondering why your results don't match up with somebody else's. It's always important to say what is the temperature and humidity of your mouse room.
Great. We actually have a lot of questions coming in right now. So let's take a question from, I believe the name is Lay. Can you comment on single house versus group house when studying mice at 30 degrees and somewhere between 4 and 6 degrees, meaning a cold temperature?
That's a great question. So this is something that there's been a lot of work done in the literature. Group housing mice in general is considered a best practice because they're social animals. Most of the way that they're going to act is going to be very different if they're group housed or singly housed. So group housing is always a good recommendation anyway, very specifically for temperature. So we know that if you're group housing mice, they're able to huddle together to keep warm, and the internal temperature of that individual cage is likely to be higher than the outside room. There are some really great metabolic cages that actually let you measure the temperature within a cage. It would be nice if we all had access to that, and I understand that we don't, but it's something to keep in mind that if you're group housing mice, it will be warmer in that microenvironment than the general temperature of the air that humans are working in.
Yeah, and that brings up another question, just asking about natural adaptations of mice. So another viewer wanted to know how mice are adapted to live under the snow, and that's a great point. So mice live together; they're huddled together, and they're able to keep warm that way as well. Let's see. Do you happen to know how the heart rate of the mice correlates with temperature?
It does. So there have been some really fascinating publications out there that you can find with a really quick PubMed search. I can't remember off the top of my head in which direction it goes, but I know that mouse heart rate is definitely affected by the temperature they're housed at. I know that there are differences between 22 degrees and 30 degrees. I believe that as the mice are kept in higher temperatures, their heart rate goes up, but it might be flipped. But I do know there's very significant differences, I believe up to double the resting heart rate, depending on which particular environment they're being housed in. So this brings up a great point that these mice are undergoing not only differences in the fat that they're burning, there's really interesting differences in brown adipose tissue and white adipose tissue in mice that are all going to be affected differently based on the temperature they're housed in. But cardiovascular studies are really important to keep in mind what temperature you're using, not just for things like heart rate, which is really important, but there's one really interesting study that actually shows that we know that chronic inflammation is a risk factor for a lot of different diseases, metabolic and otherwise. And if you're housing your mice at thermoneutrality, so something like a 30 degrees C versus a cold stress, you can actually uncouple the inflammation that's being caused by adipose tissue from something like an obese mouse model compared to systemic inflammation. There's really interesting studies showing that atherosclerosis is greatly increased in mice housed at 30 degrees C. These mice are not undergoing cold-related stress, and so you start seeing this huge increase in vascular inflammation, which actually better models a lot of human metabolic disease studies. So doing cardiovascular studies, whether or not they're metabolic related, it does matter what temperature you're housing your mice at.
All right. I do want to make a comment on another question. So someone asked, what about the Jackson Laboratory? Do we house our mice at thermoneutrality? And I can comment on that some, and you can too as well, Danielle. So we keep our mice in ventilated cages. And so the temperature actually inside the cage is warmer than what the air temperature outside the cage is. So our actual animal rooms might be held at around 72 degrees Fahrenheit, but it's actually quite a bit warmer inside that cage. And I don't remember exactly what the temperature is off the top of my head. I want to say it's 75, 76. Does that sound right to you, Danielle?
That sounds right. I think it'll vary depending on a couple different things, which is another point that it's kind of, it seems like a tiny detail, but keeping in mind where your mice are within a rack can also make a pretty big difference in temperature. To Caitlin's point, the inside of a cage is going to be a different temperature than the outside of the cage. And in addition, if you have a huge rack filled with all of your mice, the mouse in the very center of that rack is going to be in a warmer cage environment than one perhaps on the edges where there's more airflow. There are ways that you can help reduce variability. As Caitlin mentioned, having individually ventilated cages can help keep these numbers a little more consistent. But a lot of us work with mice in static cages where you're not able to control it on such a micro level environment. So it's just important to kind of keep all of those things in your mind as you're formulating your hypotheses and interpreting your results based on where those mice might be housed.
Right. And there's also another study that I wanted to mention looking at changing the temperature for the mice and how their mean energy expenditure changes based on what temperature they're held at. And the interesting thing is that if you house mice at 21 degrees Celsius and then you return them to 30 degrees Celsius, their mean energy expenditure and resting metabolic rates go back to normal. So, for example, if you were to purchase mice from the Jackson Laboratory and those mice were housed at a lower temperature and you decide to go ahead and keep your mice at a higher temperature, these mice are going to eventually get to thermoneutrality.
And that's something that I know that we tell everybody when they receive mice from the Jackson Laboratory is we always say there should be at least a 2-week acclimation period before you do any experiments on your mice. And that takes into account a bunch of different possible environmental conditions, but temperature is one of them for sure.
All right. In our last couple minutes, Danielle, I know you had some examples of other research areas that can be impacted by temperature. Do you just want to briefly mention those?
Definitely. So it's not just metabolism when we're looking at obesity or diabetes or cardiovascular diseases where temperature becomes important. There is a huge amount of literature showing that different temperatures can affect things like cancer. So it's shown that, again, mice that are under cold stress oftentimes have a dampened immune system. And so this affects things like cancer in the sense that the immune system isn't able to ramp up as quickly as we would want it to. So tumors grow at a different rate in mice that are under cold stress versus mice that are at thermoneutral temperatures. Similarly, when there's bacterial infection involved, you want to make sure that you know what temperature the mice that you're working with have been housed at, because the immune system will actually react differently to cancer infections as well as bacterial and viral infections at a different rate depending on their temperature. And that's not to say that any of these studies that are done aren't useful and don't provide us accurate information. It's just that there's different environmental conditions that need to be taken into account when you're thinking about this. And one of the things I haven't mentioned actually is this goes in the opposite direction as well. You can't just crank up the heat in your mouse room and think that everything is going to be normal, because the body is going to react differently metabolically as well as with cancer and bacterial infections quite differently if the mice themselves are sweating. And so this brings me to kind of my last point, is that there's definitely a window where the mice are going to be best suited to their temperature, but that's going to be actually different based on if they're in the active cycle of their day or if they're sleeping. So we can't just say crank up the heat in all your mouse rooms and they're going to be fine. We should probably look at possibly putting together some sort of cyclical temperature regulation in an ideal mouse room. Mice need cooler temperatures similar to humans while they're asleep in order to maintain thermoneutrality. And there's a bit warmer temperatures when they're active and running around. So there's a lot of different factors that can be taken into account. But just to let you know, it goes well beyond metabolism, cancer studies, bacterial infection studies, a lot of things with ophthalmology. The shape of the eye will actually change based on humidity and temperature in mouse rooms as well. So lots of other fields are touched by this, not just metabolism.
All right. Well, I think that's all the time we have for questions this week. We've linked a few resources in our video description, and I'll go ahead and post some links to some of the studies we referred to today. So, Danielle, I want to ask you if you just have any final thoughts that you want to leave with our viewers.
No, thank you everyone for joining us today. I think this is a great topic. I think that there's a lot of room for improvement when we're trying to get preclinical results into the clinic and ways that we can actually make the mice even better models in order to more accurately look at therapeutics.
All right, so our next Mice Tech Talk is called Let's Talk COVID-19 Mouse Models, which will be on March the 2nd. And we look forward to seeing you on LinkedIn and YouTube then. So this is Dr. Caitlin Gillens